Okay, so far we've talked about two statistical methods. So these are tools for looking at populations, and we were able to say, with a sample of data, you could then make a big, bold claim about what's going on within a population. We talked about confidence intervals, then we talked about two different tests of hypotheses for testing claims that somebody in power has made about a single population. So again, we can think about, say, the president of the university making bold statements about what life is like for students, saying things like, on average, students spend a certain amount of money on rent, or on average, students identify as, well, I'd say we could say, yeah, on average, they spend a certain amount of money on rent, but we can also imagine that the president can make claims about proportions too. So they can make claims about the proportion of students on campus who identify as female, the proportion of students who identify as freshmen versus non-freshmen, things like this. So far, that's all we've been talking about. The idea that there's some single population out there, and then there's some person in power who's making bold claims about what's going on in those populations. And then the methods we talked about are the tools we use to go into those populations, collect data, and assess those claims. So that's one collection of methods. Now another collection of methods, and these are the methods we're going to talk about today, have to deal with looking at multiple populations and being able to tell whether or not these populations are different or not. So in our minds, we might think about there being different populations. So if you take the entire Southeastern student body and you cut it into sections, you might have a group of people who identify as female, and then everybody else, right? So we can think about these two groups, and we might recognize that on average, what happens in one group might be a little bit different than what happens in another group. Or maybe there really is no difference between two groups. So we can imagine that, maybe with the fear of crime survey, we're interested in this variable fear of crime. We might think that there could be gender differences. We can also think about things like how much, say, money people pay in rent. And maybe we would say, well, maybe there is no difference between people who identify as female and non-female. The rent is kind of a fixed thing. You see the ad in the paper, they're not going to cut you a break because you have one identity or another. So again, all of these methods that we're going to talk about kind of moving forward are about comparing different groups, different populations. So here's kind of a thought experiment of sorts. So here we have two populations. So we say population A and population B. So then let's say we go out to population A and take a random sample. We get this stuff. And then we go out to population B, we take another random sample, and we get that stuff. So looking at these two circles, these two samples, we can look at the color of the dots within them. And I think immediately we can all see that these two groups are different, right? So which group has more yellow dots? Okay, so right. So sometimes we get really lucky. So we go out into these populations, we take a random sample from A, random sample from B, and when we look at the data, it's really clear that there's a difference. So the problem with random sampling is that it's random. There's an element of chance. So I'm sorry to break it to you guys, but you can get unlucky in life and you can draw a bad sample, or maybe not the best sample that you could draw. So here we have, again, two samples. And it could be that sample B is different from sample A. But in this situation, the sample we got, kind of hard to tell. We got this sample is not nearly as good as the one we got in this situation. So it's possible that sample B is still different from sample A. And it could be that there is a true difference. But it's also possible, again, just due to random chance, that we got a lousy sample. Or it could be just by random chance alone that there is a difference when really there isn't a difference. So a lot of the statistical methods we deal with are about making that call, about saying, okay, there's going to be some threshold, and if the data are different enough, then we'll say they're different. So sometimes we get lucky and it looks like this. So if we looked at our data, we'd say, of course they're different, and then the statistics would of course come out and say, yeah, there's a difference. But sometimes we really do need the statistics themselves to look at our data and really let us know if a difference is there or not. Because even by just looking at the dots, it can be really challenging to see if a difference exists. Okay, so again, there's this idea that when we're comparing groups, we really want to make sure that there's a real difference and that the difference we see isn't just due to random chance. Again, there could be two populations, take a random sample from one, random sample from other, and just by dumb luck, we get some lousy samples, and it's really difficult to tell the difference. So, we want to make sure that if we do decide that they're different, then there's enough evidence to make that claim above and beyond just random chance. So the first method we're going to talk about is the difference between two population means method. And this is the only method we're talking about today. So at this point, this will be our third method. So we talked about the method for examining claims about a population mean. We talked about the method for examining claims about a population proportion. And today we're going to talk about this method for examining, I guess you could say, claims or examining the difference between two population means. So similar to the other methods we talked about, this method only works under certain conditions. So this method works when we're interested in two variables. And we use the terms independent and dependent to talk about these variables. And so this is like the scientific terminology that's used. So what this is really just kind of doing is giving us a unified framework, a unified language. So if we talk to somebody in another social science, or we talk to somebody in, say, biology or physics, then we can talk about independent and dependent variables, and we all kind of like know what we're talking about. But as far as the intuitive meaning, you want to think of it as we have our independent variable, and that's really just a fancy way of saying what is the variable that indicates how the groups are different. And then your dependent variable is usually the variable that you really care about. So think of it like you're doing, say, fear of crime. You're really interested in fear of crime. So you want to know about the average fear of crime. And in this case, that becomes your dependent variable. And you might be interested in how fear of crime differs between groups. So you might be interested in how fear of crime differs between people who identify as female and non-female. Or you might be interested in how fear of crime differs by freshmen or non-freshmen. So the independent variable, that's the variable that defines the groups. So you'll imagine it'll be things like gender or the dichotomized academic class standing. So whenever we're thinking independent variables, think levels, think categories. Now, whenever we're talking about dependent variables, you want to think about interval and ratio level variables. So think about fear of crime, safety feeling, how many drinks somebody consumes, how many drinks they think students at Southeastern consume. Think about housing satisfaction. Think about number of problems with housing. Think about how much people pay or think they should pay. So this method works for this situation. We have two groups and we're interested in comparing some continuous thing between the two of them. Now, in order to use this method, we have 4 assumptions that we have to check out. So the first assumption assumes that there are two populations. So you'll look at your variable that separates the individuals in your sample, and there should be only two possibilities. So it could be female, not female, freshman, not freshman, rural, not rural, or however you've broken it up. Number two, it's going to assume that we're talking about population means. Whenever we're interested in comparing two population means, this is the method for us. So if you hear any questions or you've got a variable that only makes sense to think about in terms of proportions, then don't use this method. Three, we have our independence assumption. So again, this is the assumption that everybody who responded to your surveys were not influenced by anyone else who took that survey. Now there's a fourth assumption here, and it's not so much an assumption in the sense that there are two paths that this method can go down, and you have to pick one path or the other. So this is the equal or unequal population standard deviations. So this is the idea that in the populations for your two groups, that the amount of diversity in one group is either the same as the diversity in the other group, or that they're different. So you can think of it also in terms of maybe consistency. So you might have one population that's very consistent in their views and opinions. There's some variation, but not a lot. And you might have another group who is very inconsistent. So you might think about this maybe in terms of, say, something like academic class standing. So when freshmen get to Southeastern, they're from all over the state. They have no idea what college's life is going to be like, right? So some of them are going to come here and be day one ready to hit the books. Others are going to think, oh, it's all about partying. There's going to be a lot of diversity of what this is all supposed to be about. But if you start looking at juniors and seniors, maybe things start to become a little more homogeneous. So everyone is getting ready to graduate. Everyone's getting a little more serious about making sure that they have all their credit hours in, they have all the right grades they need. So maybe they don't party as much. I don't know. So there's going to be this fourth assumption, and you're going to have to think about the consistency between the two groups. You think they're equally consistent, then you're assuming that they are equal population standard deviations. If you think that one group is more erratic in their responses than another, then you're going to say that they have unequal population standard deviations. And this is important. So here we might have two populations. So maybe population A consists of everybody who identifies as male, and we'll just say population B consists of everyone who identifies as female. And so this is a population, and that's a population. So one thing we can notice is that the population averages for these two groups are different. So population A is to the left, population B is to the right. There's a gap between them. However, we can look at this and think that the population standard deviations are the same. So as far as like how spread out the values are, they're exactly the same. So this circle is just as wide as that circle. So if we had population data and we were to look at all the responses between these two groups, and we saw this, then we might get the sense that these two populations are different, right? There's no overlap between them. However, if the population standard deviations, if they're different, then we could be in this situation where there is overlap between the two populations. So, you can think about it in terms of, say, fear of crime. Maybe when you ask all the people who identify as non-female how fearful they are, all their responses are pretty consistent, right? So all guys kind of like grow up with this like macho idea in their heads that crime doesn't exist, that they're not going to be victimized, all that kind of stuff. So there's like a really consistent worldview. But then, when we talk to people who identify as female, there might be more variation. So you're going to have some women who have the same worldview as the guys. So they think to themselves, crime's not a big deal, doesn't happen nearly as much as people talk about. I'm safe, I know how to handle myself, things are fine. And you might have some people who are maybe more in that sort of traditional mindset where they're like, well, you know, as a woman, I have to be more concerned about X, Y, and Z. And then you might have some people who are really at this kind of higher extreme. So, you know, these are the people that are sort of hyper vigilant when it comes to issues of crime and safety. So if we're in this kind of situation, so if there's a difference in terms of the spread of these two populations, then under certain circumstances, it can be really difficult to tell that these two populations are different. So especially if they overlap. So when we're in this situation, equal population standard deviations, equal consistency, it's a lot easier to, I guess, say when they're different than when the population standard deviations are different. So here there's overlap. Showing that these two groups are different is going to take a lot of work. Here there's no overlap. Showing that these two populations are different is going to take less work. So when it comes to using this method, you're going to have this path. You have to decide which one you're going to go down. So you're going to have to decide whether or not you think the population standard deviations are equal or not equal. And again, think about things like consistency, inconsistency, people being erratic, or diversity. If it's equal diversity and the population standard deviations are the same, you think one group has greater diversity than another, and you would say population standard deviations are different. Okay, so this is going to be really important. We have to check our assumptions. And when it comes to using this method, that fourth assumption is going to, again, come into play and let us know which SPSS tools we're going to have to use in order to make conclusions about these two populations. Now, when it comes to using this method, we're going to use the same 6 steps that we talked about with the 2 previous methods. So everything that's on this slide, we've already seen before. Well, except for the title. So if you wanted to do, say, a difference between 2 population means method, assuming independent samples and equal population standard deviations, and we go through these 6 steps. So step 1, we want to state our null and our alternative hypotheses. Step 2, we set our significance level. So we usually conform to the scientific standard of setting it to 0.05. Step 3, we determine the appropriate statistical method. So in this case, whenever we're comparing 2 population means, and we think that the populations have equal standard deviations, then we're talking about this method. And then we check all of the assumptions. Step 4, we then take our data, put it into SPSS. SPSS is going to give us an output. Sometimes the defaults are going to be correct, other times they're not. So we'll have to take that output and use it to find our correct p-value. Step 5, we're then going to compare the p-value to our significance level. And of course, we have our mantra. So even in this situation, the p-value is less than the significance level, and we reject the null hypothesis, always. And then step 6, we interpret our results. So we're going to go through this huge process to figure out whether or not there's a difference between 2 groups. So we want to eventually pull our heads out of the details and then kind of look at what we've got and say, yes, the groups are different, or I guess a better way to say this is, yes, the population means for these 2 groups are different or not different, depending on how this works out. Okay, what questions do you have for me? Okay, feel free to raise your hands as the questions come to your minds. So we can think about doing this kind of, using this method in the context of the juvenile recidivism study. Again, imagine a population of youth who have recidivated, who've been involved with the justice system multiple times. So for each of these youth, we can figure out how many days it took them from being, say, released from the system to being involved in the system again in the future. And we might be interested in how recidivism changes from year to year. So we might have, say, data from 2012 and data from 2013. We might wonder, well, is recidivism up or down from one year to the next? So in this situation, our dependent variable is recidivism. So it's the number of days until next offense. We're talking about a very continuous thing. So in your work, it's going to be, again, fear of crime, number of drinks, number of housing issues. Now, as far as our independent variable goes, in this case, it's year. And it works because in this situation, we only have two categories, 2012, 2013. We can even see that this independent variable is ordinal. So 2012 comes before 2013. So what we can do is we can look at these as two populations. All the recidivating youth in 2012, all the recidivating youth in 2013. We can go to the 2012 population, take a random sample. We can go to the 2013 population, take another random sample. For each population, we can calculate its own sample mean. So here for 2012, we get a sample mean of 262 days, roughly. And for 2013, we get a sample mean of 377 days, roughly. Now, if we look at these standard deviations from these samples, we'll see that the sample standard deviation for 2012 was 238 days. And we can see that the sample standard deviation for 2013 was 350 days. So, when we're thinking about this idea of populations, standard deviations, and them being equal or not, this is something that we have to think about as researchers. So we have to make that call based off of our understanding about these groups. So we don't do it based off the data. So even if you go into your data and you calculate it and it comes out different, that's not what you want to use to decide whether the population standard deviations are equal or not. Again, it goes back to this idea, maybe we got unlucky, maybe our random samples from these populations aren't that great, so that's going to affect the people we get, and it's going to affect all the numbers we get to see. So when it comes to this situation, we might be interested in questions like this. Is there a statistically significant difference in recidivism between 2012 and 2013? So when it comes to doing this formal test of hypotheses, we have our first step, which is we state our null and our alternative hypotheses. Now, when it came to the methods we've talked about before, we've usually talked about this person in power. So if you're ever thinking about figuring out what your null hypothesis is, and we talked about this idea that there's going to be someone in charge, someone who is either like a warden or a president or CEO, talking about how things are for a lot of people. Now, when it comes to doing this method and identifying the null hypothesis, I want you to change your mindset a little bit. So instead of thinking about a person in power, I want you to draw on your imagination and think about I guess you could say a doubting scientist. So I don't know how popular this idea is anymore, but it used to be that when people would think about scientists, they'd think of them as being these like really doubting kind of people. So these are like skeptical people who, if you tell them anything about how the world is, they're going to look at you and say, I don't know, it could be like that, but first I want to see the evidence. I don't know, is there like some, I guess, stereotyped group out there that's like more cynical than another that you know of? Like, I don't know, sometimes I think about, atheists? Yeah, maybe. So you might think of it as like an atheist scientist who says that, nothing is happening unless there's evidence for it. Sometimes I think about like Russians as being like skeptical people. I think there's like a popular cultural idea about this. I have like a Russian background, so I feel like it's okay for me to pick on this group. So the point here is that in your mind, think about a doubting scientist. Think about someone who's very skeptical, who, until there's a lot of evidence, they're always going to say nothing is happening, and that the groups are the same. So if you ever see some kind of blurb talking about, what's going on within between two populations, and it talks about how somebody thinks that they're the same or not different from each other, then maybe you're doubting scientist. Or if you're asked to come up with a null hypothesis, you want to imagine yourself, so you put on your doubting scientist hat, and that's how you figured out your null hypothesis. The null is always going to be, these two groups are the same, there's no difference between them, there's nothing interesting happening here. The alternative hypothesis is going to be that there's some kind of difference. So again, when it comes to the alternative hypothesis, there's only going to be 3 different kinds that we can choose from. And these are the same 3 different kinds that we talked about previously. So it could be that the 2 groups are different, but we don't know how. It could be that the first group is greater than the second group, or it could be that the first group is less than the second group. So again, it could be this idea with population 1, population 2, and population 1 on average differs from population 2. Somehow, we don't know how, but we think there's a difference. Or we could be in the situation where the population average is, say, greater for population 1 than population 2. Or it could be that the population average for population 1 is less than the average for population 2. So the alternative hypothesis is always going to be that there's a difference. And then we have to kind of specify which type of difference is going on. Sometimes that'll be given to you in the assignments in this course. Other times you might have to think about it based off of your own knowledge about different groups. Now, I want to make a very strong warning here. So the order of your populations and how you talk about them matters. So you're going to come up with a null hypothesis. So it could be something like this. So the mean of population 1 equals the mean of population 2. Now in reality, you can make that same claim by stating that the mean of population 2 is equal to the mean of population 1. Right? So if you look at these 2 claims, they're basically saying the same thing. So read it from left to right, right to left. So if we go from left to right, we get 1 equals 2. If we read the second one from right to left, we get again 1 equals 2. So conceptually for us, it's going to be, we're going to be in the situation where we're going to say that the 2 population means are equal, but it's going to be really important that we specify that ordering. So whenever we're talking about the null hypothesis, whenever we're making that doubting scientist claim that there's no difference, that the 2 populations are the same, we actually want to provide a little more information. We want to say population 1 equals population 2. And whatever we define population 1 to be, or population 2 to be, we have to be very consistent about that. Otherwise, SPSS is going to give us all kinds of junk. So here's sort of how it works. You might have a null hypothesis like this. So here we have the population average recidivism for 2012 equals the population average recidivism for 2013. So in this situation, my population 1, my group 1 is to the left of the equal sign, and my population 2, my group 2, is to the right of the equal sign. So when I'm doing things in SPSS, I have to specify what my 2 groups are, and I have to specify the order for those groups. So here, because the population mean for 2012 is to the left, that's my group 1. So I put that in group 1. And then here I have a population mean for 2013 on the right. So that's my population 2. So that goes into group 2. So this can become kind of challenging when we're talking about categories that are not ordered. So if you're talking about gender, and you're, say, comparing females to non-females, then this is females on the left, and this is non-females on the right. then you need to make sure that females are in group 1 and non-females are in group 2. But if you're talking about things in reverse, if you talk about, say, non-females being on the left and females being on the right, and then what you put into SPSS should also switch. So then it would be non-females as group 1 and non-females as group 2. For step 2, we set our significance level. So here we just set it to the industry standard of 0.05. So again, the idea here is that if we went out to these two populations and we took random samples from each and we compared them and we saw, say, some kind of difference or some kind of result, and then we went out and did that again, we went back to those two populations and we each took another random sample. And then we went back to those populations again and took two more random samples. And we just did this again and again and again. 5% of the time, we're going to make a decision about the null hypothesis, and 5% of that time, it's going to be wrong. And 95% of the time, over the long run, it's going to be correct. So here for step 2, we set our significance level usually to 0.05. Step 3, we then determine the appropriate statistical method and check our assumptions. In this situation, we're doing a difference between two population means method, assuming the independent samples and the equal population standard deviations. So I'm assuming that there are two populations. This is okay because I'm comparing two possibly different populations. The second assumption is that we're talking about population means. So this is okay because we're comparing two population means. So I'm talking about average recidivism for 2012 and average recidivism in 2013. Assumption 3 is our independence assumption. So here we're assuming that when it comes to the youth in these populations, that the amount of time it took one youth to return to the court did not have any effect on how long it took some other youth to return to the court. And then 4, we have to make a decision about that equal or unequal population standard deviations. So again, we're thinking about diversity, we're thinking about consistency. So I think about all the youth who were recidivising in 2012, and I think about how consistent they were in their recidivism. I then want to think about that and then compare it to the consistency of the youth in 2013. So based off my own experience, there weren't any major policy changes or practice changes within this jurisdiction within these 2 years. So I don't really have any evidence to suggest to me that these two populations would be different in how consistent they are. So you want to think about your two populations. If you can clearly find some reason why one population is going to be more consistent than another, then you have to make the unequal population standard deviations claim. But if you think really hard and you can't find a good reason for why one would be more consistent than the other, then it can be safe to say that the equal population standard deviations assumption is satisfied. Okay, so step 4, we determine our p-value. So we take all of our data for each of the two samples, put it into SPSS. Since we made our assumption that the population standard deviations are equal, we're going to focus on just these top rows. So from this, we're going to pull out our t-statistic and the value into the sig two-tailed. So this could be the p-value. Sometimes it's not. So sometimes it's not, so we have to go to the flowchart. And there's an entirely new set of flowcharts that you can find on Moodle. So here we have a flowchart for the method we're talking about today. And then next time we meet, we're going to talk about proportions. So there'll be a different flowchart. So the way this works is we bring together our null and our alternative hypotheses. We bring that together with the results from SPSS, and then we combine those together with our flowchart. So if we look at our alternative hypothesis, we're talking about a difference between 2012 and 2013. We're not specifying how they differ, we're just saying some difference is happening. So our alternative hypothesis tells us that we're doing a two-tailed test. So we go to the flowchart, we have three major sections: two-tailed, upper tail, and lower tail. So since we're doing a two-tail, we focus on this first bullet here. So we're doing a two-tail. So we're basically saying that our alternative hypothesis is that the population average of group 1 is not the same as the population average for group 2. So when we're in this situation, we can use the p-value provided by SPSS. So in this situation, the default is correct. So here our p-value comes out to be 0.195. And then the rest of it is very similar to what we've talked about before. So here the p-value equal to the 0.195 is greater than our significance level. So it's bigger than 0.05. So since our p-value is greater than our significance level, we're going to fail to reject the null hypothesis. In step 6, we interpret our results. What does it mean to fail to reject the null hypothesis? So we basically say that at the alpha equals 0.05 level, we have insufficient evidence to conclude that there is a statistically significant difference in recidivism between 2012 and 2013. Or in more simple language, it's possible that the recidivism rate was the same for both years. Okay, so sometimes we're going to be in that situation where the population standard deviations are equal. And again, this is an argument. We'll never look at our data to figure that out. You need to draw on your own personal experiences. So you've all been students, you've all been freshmen, sophomore, some of you are juniors, some of you are seniors. So when you're thinking about your own research, you want to think about your own experience and your own understanding of what life is like here at Southeastern for students. And you're going to use that information to make this call about this population standard deviation business. So what we talked about just now was all about when the population standard deviations are the same. Now we're going to talk about what happens when they're different. And by and large, everything is the same. The real major difference is that when these are not the same, we're going to look for different values in our SPSS output. So here we can do these 6 steps. These are all the same. So except for here, we're doing this difference between two population means method, assuming independent samples and unequal population standard deviations. So again, we might turn to this juvenile recidivism study. So here we have recidivism between, say, 2012 and maybe in this case, 2014. So in the state of Kansas, where these data were collected from, there was this new bill that was passed called Senate Bill 367. So basically what they did is they shut down all of the group homes. So they still have like juvenile detention centers and they still have juvenile correctional facilities, but the kind of like halfway house, they were finding that those weren't working and that they were actually just costing a lot of money. So what they decided to do was to shut those down and reinvest all of that money into services in the community. So more programs, kids staying at their homes, kids receiving programs in the community or with their schools. So because there was this new law that was passed and all this new money appeared and there was this new effort to kind of change how juvenile justice works, this lets me think that maybe there's going to be some difference in the population standard deviations between 2012 and 2014. So you can think of it like in 2012, people were just kind of doing business as usual. And then this new law passes, everyone gets really excited. We're finally going to have funds to help the kids in the community. So we have new trainings that come out. We have new programs that are available. Everyone is really excited and focused on helping the youth. So because of this law passing, this makes me think that when it comes to recidivating in 2014, that they're going to be a lot more consistent in how they respond than in 2012. So in 2012, the kids could have been all over the place, but now in 2014, we've got a really focused juvenile justice effort. So we're going to imagine that there's still going to be some differences between the kids, but they're going to be a little more consistent. So here, our dependent variable is still recidivism, it's still continuous, still this ratio level measure, and our independent variable is still going to be year. So in this case, it's 2012 and 2014. So we might be in this situation where we are interested in the mean recidivism in 2012 and wondering if it's going to be statistically significantly less than the mean recidivism in 2014. So recidivism is kind of like a strange measure to think about. So more recidivism on average is a good thing, in the sense that what that means is that on average, it's taking youth longer to come back to the system after they've been involved. So think of it like, youth gets involved in the system and we don't want them to come back, ever. Some youth do. And the best sometimes we can hope for is, well, if we can't prevent them from coming back entirely, then hopefully we can at least give them some tools so that if they do come back, it doesn't happen, the month after they're released. So we have our step one, we state our null and our alternative hypothesis. So we have our null, this is our doubting scientist claim. So our doubting scientist is going to look at Senate Bill 367 and say, this isn't going to change anything. You're shutting down the group homes, great. You're going to give a bunch of people a bunch of money and nobody's going to do anything useful with it. Right? Doubting scientist claim. But based off of our experience with the juvenile court, maybe we think that this is going to change things. The youth are going to be better off now that they have more resources available to them. And maybe that they're going to be better off now that they're going to be treated in the community. So our alternative hypothesis here is that recidivism in 2012 is going to be less than recidivism in 2014. Again, the order of our claims is really important. It's going to be really important when it comes to putting the data into SPSS and getting correct results. So in this situation, I have my null set up to where I'm saying that the population average in 2012 is equal to the population average in 2014. Population average for 2012 is on the left. Population average for 2014 is on the right. Population in 2012 is our population 1, our group 1. And then the population on the right is our 2014. Our population 2, that's our group 2. So we want to make sure that when it comes to SPSS, that group 1 is 2012, group 2 is 2014. We also have to figure out our alternative hypothesis. So in this situation, again, really hopeful that this Senate Bill 367 is going to change things. So I definitely think that the recidivism is going to be really elongated, so to speak. So when it comes to the youth, they're going to take more and more days before they're involved with the system again, after these new programs have been implemented. Step 2, we set our significance level. So here we set our alpha equal to 0.05. So again, we're looking at this population of recidivating youth, population of youth in 2012 and 2014. And I'm going to use this method to decide whether or not there is a difference or not. In fact, we're going to use this method to decide whether or not recidivism has increased on average in 2014 versus 2012. And there's always going to be a chance that we're wrong. Right? I'm going to reject the null or not. And I can't get rid of that fact that there could be a mistake happening. But by setting the significance level to 0.05, what I'm saying is that if we were to do this study again and again and again, 5% of the time, whatever decision I come to is going to be wrong. But then 95% of the time, over the long run, the decision I'm going to come to is going to be correct. So we set alpha equal to 0.05. We then determine the appropriate statistical method, and we check our assumptions. So here we're still working within this difference between two population means method, assuming independent samples. In this case, we're assuming unequal population standard deviations. Again, we can assume that there are two populations. Okay, because we're comparing two possibly different populations. Number two, assumes about population means. Again, this is okay because we're comparing two population means. 3 is our independence assumption. Again, it's this assumption that when it comes to these youth and how long it takes them to recidivate, that for one youth, how long it takes them to recidivate is not going to depend on how long it takes any of the other youth to recidivate. 4, we then have to pick which path we go down, whether it's the equal population standard deviations or the unequal population standard deviations. In this case, we're going down the unequal population standard deviations path. Again, we get this idea that there's going to be some kind of greater coordination in the provision of services and treatment in 2014 than 2012. So we're going to expect a lot more consistent results than in 2012. Step 4, we then go to SPSS. We put our data into it. We have to crunch the numbers for us, and we get some results. So because we are making this assumption that the population standard deviations are different, we focus on the second row of this output. And from there, we pull out our T statistic and this sig two-tailed value. So we get some results from SPSS, but when it comes to the p-value, sometimes SPSS is wrong. So we have to modify that p-value sometimes. So in order to do this, we need, again, our null and our alternative hypotheses. We also need the results provided by SPSS. And we also need our flowchart. So again, our flowchart has these 3 different decision points. So if you're doing a two-tail test, you go to bullet 1, upper tail test, bullet 2, lower tail test, bullet 3. So we look at our alternative hypothesis, and here we're saying that the average recidivism in 2012 is less than the average recidivism in 2014. So we're doing a lower tailed test. So that tells us we go to this third bullet here. Then we look at and see that there are 2 more bullets. So if T is positive, we do one thing. If T is negative, we do something else. We look at our T statistic, and it's this negative value. So this is going to put us at that second bullet. So if T is negative, then our p-value equals the default value divided by 2. So here our p-value is equal to 0.054 divided by 2, which is 0.027. So step 5, we then compare our p-value to our significance level. So here the p-value equals 0.027. This is definitely less than 0.05. So we reject the null and we accept our alternative hypothesis. And in step 6, we interpret that conclusion. So at the alpha equals 0.05 level, we have sufficient evidence to conclude the mean recidivism in 2012 was statistically significantly less than the mean recidivism in 2014. So I guess you could say in more everyday language, the average recidivism in 2014 was larger than it was in 2012. So the idea is that on average, the youth were taking longer to come back into the system in 2014 than they did in 2012. Okay, so as far as really today's lecture goes, we're really just focusing on population averages and being able to say, okay, we have 2 populations and let's compare them and see if they're different or not. And again, it's just talking about things in terms of their averages.